I'll give you a break right now, but let me just put the question and I'll give you a break. Okay? That's a glass slab. Okay? Suppose it's a glass slab. Suppose I have a white light incident on the glass slab, right? That's the whole line it should go through, right? But obviously it doesn't go through that line. It will bend, right? And will come out, right people? Right people? So this line is just a reference line. Because we have already done that, it comes out parallelly. Have you done that? Have you done that? Have you done that? Guys? Guys, have you done that? It comes out parallelly. Yes or no? Yes or no, people? Anybody there?
Yes, sir, we did it.
Like in which section, which class, what theory?
Sir, the refraction.
Okay. What's the reason it is coming out parallelly? Because that I'll just quickly tell, because a lot of people are not even saying that they have done it. Your Snell's law is always going to hold, right? This was I, this was R. Then what is sin I by sin R? What is sin I by sin R? Mu of glass with respect to air, right? It is going to the glass from air, right? 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 This is R. Now the angle of incidence over here will be R because they are internal opposite angles, right? Because it's a parallel glass slab, their normals are parallel to each other, right? Right? So this is R. And this angle, God knows what it is, say angle of emergence. Is that clear? So what is the incident angle now? R is the incident angle, right? Right, people? Sin R by what is the refraction, angle of refraction? Sin E is equal to mu of what? Where it is going to? Mu of air with respect to glass, which are ulta fulta of each other, right? Right? Mu of air with respect to glass will be simply 1 of mu by mu of glass with respect to air. You know all this, what I'm saying, or it is all gibberish? You know all this?
Yes,
Guys?
sir.
Okay. Get the point? So sin I by sin R was mu of glass, and sin R by sin E is mu of air with respect to glass, meaning to say 1 by mu of glass, right?
Yes,
Right?
sir.
Right? So if I equate the two, then what do we get? What do we get? That I is equal to E, right?
Yes, sir.
Right? 1 by this is that. So I will come equal to E, right? So if I comes equal to E, then it means what? They are parallel, right?
Angle of emergence.
Yeah. So that means they are parallel, right, guys? Right, guys? This was your I. I'm making some other ray, and with the normal, it is at I again. So these two must be parallel, no? Right, people? Is that theory okay with you guys? Yes, no?
Yes, sir.
Okay. Now let us put the twist of dispersion over here. So my question is, if there is bending, it is constituent colors would have bent differently, right? Suppose it is not a monochromatic light, it is not a single color light, it is a white light, then it will give you all red and everything, right? Right, people? Right or not? Right or not?
Yes, sir.
red will bend not so much, violet will bend yes a lot, okay, something like that, and then they will come out. If I apply the same concept which I did for white light, all mu's, mu of red is a certain constant, mu of violet is a certain constant, they are different, hence they give different angles, by the way. Okay, so if I do that, I'll get violet coming out parallel to its own violet light earlier. So this guy had a violet light in it, right? Right? And red will come out parallel to its own red light earlier, and this original light had a red in also in it, right? Right, people? Right, people? So my big question over here is, why don't we see a spectrum when we see light, which comes a lot in the question in the paper? Like, why don't we see a rainbow or a spectrum when we are seeing, when we pass white light through a parallel glass slab? Is the question clear? Is the question clear? Is the question clear? Is the question clear?
Can you repeat the question once more?
Okay, do you deny that white light is made up of VIBGYOR? Do you deny that? No, right?
No, sir.
Among the visible VIBGYOR and other lights also, but VIBGYOR, right, is our concern. So when it will go to the, when it is going to go and strike the glass, the light doesn't know that it is striking a prism or a glass, right? Does it know?
No,
So
sir.
it is going to disperse over here, right? Is it going to disperse or not, people? It's going to disperse or not?
It will, sir.
Yes, people, it is going to disperse or not? Light goes, strikes, it doesn't know like it is entering a slab or a prism and all. It is going to disperse because it is going to bend according to its wavelength, right? Right, people? तो यहाँ पे disperse हो गया है. There is no doubt about it. So if it has dispersed, then it strikes on the other surface at two different points, obviously, and then again it will bend back because it is going to go from denser to rarer, so it is going to go away from the normal, and it is going to bend back such that it becomes parallel to its original one, right? Right? Because of that sine thing, cos thing I showed, right? Not the cos thing, but the sine thing, right? So there is no doubt about it. So I am telling you that that's a fact. You don't have to worry about that. That it will bend back parallel to its original path. My question is, when you have a red light coming out, when you have a violet light coming out at two different places, why don't I see a VIBGYOR if I keep a screen over here? Screen kept over here. Why don't I see a VIBGYOR? Okay, why I have to use a prism to do that? Are you understanding the question, guys? Why not a parallel glass slab? Is the question clear? 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 भाई बाकी टीचर्स कैसे पढ़ाते हैं यार तुम लोग को? Okay, so answer if it is clear. Or take your break. We'll meet at what? We'll meet at 7. ठीक है? 7 to 8 we'll do all the phenomena. Okay?
Yes, sir.
ठीक है? So try to answer this question.
So the attendance.
What attendance? Okay, write your name in the chat. Anybody answer to this? Do you understand the question? Do you understand the question? So there are two answers, one actual answer and one the answer which is making what do you say, its place in most of the textbooks, okay, which is not the actual answer. Get the point? So let us just first discuss the answer which is not the actual answer, but this is the answer where it is, I mean, most of the teachers in the school or even boards, they will require it. Okay, they will ask you to rather write that answer. Okay, what is that answer? What is that answer? That a glass slab is like two prisms combined. Is that clear? Is that clear? One prism excuse me, one prism splits the light and the other prism joins the light. Is that clear? Is that clear? It is joining because exactly opposite is happening over there, is what is claimed. Do you think this is happening, guys? Do you think this is happening? Do you think this is happening? Do you think this is happening? Yes, people. Yes, people. Are you there? Is anybody there in the class?
So I don't think the light gets refracted.
The light doesn't get refracted, you are saying?
No, and like it doesn't split into the constituent colors.
Oh, why so? Tell me. That's another take to it. That's another take to it. Yeah, why? Why it doesn't split? Because it doesn't like splitting when it is a glass slab, huh?
So no, I've never seen it splitting at least in a
Oh,
glass.
never seen. That's the question now, that why don't you absorb the split, observe the splitting if it is a glass slab? Why don't you observe it? How will it not split, man? Why will it not split? It is going from a rarer to a denser medium. Red has a different mu and violet has a different mu. Therefore, they split. Are you understanding? The mu values are different.
Yes, sir.
Okay. So this is, say, red is slightly less than 1.5 and mu of V is slightly more than 1.5. So they split. If it was a prism, they would split, right? So if it is a glass, how can the light know that, okay, I am entering a glass slab and I should not split? What is going to happen over here happens, right? So what you are saying is not right at all. It splits. It splits. If you have not observed, then if you look at the edge of the glass, no, it will look colorful to you. At least on the edge you will see the colors. Okay? But throughout throughout you can't. Anybody else? Is this happening? Is what I'm saying, asking. Is this happening that it is recombining? That's not happening. Why? Because light is going, as it is going, all of a sudden when it is coming to the middle, it will not start bending without a change in medium. Will it start bending without a change in medium over here?
No, sir.
So this is not the actual explanation, but it is widely accepted. Widely accepted, and if you write in the exams, you are going to get marks. And I am so worried that if you write something else which is the right answer, you might lose marks. So if they ask you that why you don't observe dispersion in glass slab, what are you going to write? First you are going to write this wrong answer so that the teachers are happy, whoever is going to give you marks. Okay? What is that? What is that?
The light.
The glass slab acts as two prism, one splitting it, the other one joining it. Is that clear? Is that clear?
Yes, sir.
Okay, why so such an accepted answer? Because in fact, we have arrangement of prisms where we disperse and then we combine back by something like two prisms. Okay, we do that. We actually have. So this comparison is somewhat made to that, which is okay. Two prisms actually are able to combine the light this way. Is that clear? Is that clear? So we have combinations of prism which is called zero dispersion or zero deviation. Two kinds of prism. Okay. So the dispersion prisms are there. So a combination of prisms are there. So no doubt. But this answer, therefore the answer is such a famous answer because it is not away from a certain other truth. But that's not explanation of this current question. Can anybody think of an explanation? Okay, it's little complicated and hence it is not so famous, the explanation. Okay, are you game for it? Do you want to listen to it? Would you be able to accept it? The point is we never have a single ray. We always have a bunch of rays, right? It is always a beam, right? 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 Right or wrong? We don't have an isolated ray, right? There's a ray here, there's a ray here, there's a ray here, there's a ray here. Millions and millions. We are able to draw only 4, 5. I am able to draw only 4, 5, 6. Millions and millions. Each one will be doing that split or not, right? Each one will be doing that split, right? 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 Each ray is parallel, so they will have their own, they'll have their own yeah, let me show it like this. They'll have their own splits happening like this or not, right? Right? Right, people?
Yes, sir.
चलो कंप्यूटर कहीं तो हेल्प कर रहा है, right? So ultimately I should have drawn a yellow also in between so that overlap starts happening very fast. Okay, so each of them is having parallel red Vibgyor lights coming out on the other end. Parallel Vibgyor lights coming out on the other end. So can you see what has happened now? The violet has come over the red of some other one, right? ये वाला देख रहे हो? The violet is on the red of some other light, right? Right?
Yes, sir.
इसका violet and some others red. It is overlapping or not? So the point is at any given, if lights are going to come out parallelly at any given spot, you will have all the right lights or not, all the Vibgyor coming out or not. This red from some other light, some other white light, this violet from some other white light, this violet from some other white light, red from some other white light, yellow from some other white light, because they are all coming parallelly this side. So it is going to emerge parallelly or not. So it will be a mixture at a certain spot. It will be a mixture of all of it or not.
Yes,
And
sir.
hence it is white. Are you understanding? Hence it is white. Hence this cannot happen at the edges. So the edges are little bit colored. But this can happen in the middle. So in the middle everything is white. Because in fact at any
Sir,
given
so for
spot,
all the colors, sir,
at
from
any
what you're saying in this
one
is-
second, at any given spot we have a mixture of all the colors. Violet from one of the rays, blue from the other ray, green from the other ray, orange from the other ray, all the colors, and hence it is white. Okay,
Yes, sir, understood.
so this explanation is little tricky, but what to do? Actual things are actual things, you can't wish them away. Okay, so what is your best bet in writing for the board exams? First you write what? A glass slab, number one explanation, which is wrong by the way. Okay, what is that explanation? A glass slab can be thought of two prisms as shown in the figure, one splitting and the other one combining the light. Is that clear? After you have written that, immediately after that, next paragraph you add what? The light not dispersing can also be explained by the fact that the emergent light is parallel to the incident light. That the emergent light is parallel to the incident light. Get the point? Get the point? Hence,
Yes, sir.
hence for multiple rays incident on the glass slab, there would be multiple parallel colored lights emergent from the glass slab, which would be overlapping each other, creating white light. Is that clear? So write it in a very short way. You don't have to explain much. Why? Because they'll go for the first line and give you marks over there. Are you understanding, guys? Are you understanding? So this is your dispersion. You watch this part of the video again to understand why, what's the actual reason of not dispersion phenomena not visible. Is dispersion happening? Yes, it is happening. It's not visible. Is that clear? Is that clear?
Yes, sir.
आते ही रहते हैं लोग. Now another extra knowledge for you is, if it was a prism, the lights which are coming out are at different angles. If somebody is wondering that why not same explanation goes for a prism where there are multiple lights, they are not parallel. So what is the big diff in being parallel and not parallel? The big diff is, if there is some other rays, this ray has split and given you this and this, right? There's some other rays whose, say this is a ray, whose violet light is coming on this. Okay? What happens? Is this violet parallel to the red? No, it is not, right? So are they going to combine? Are they going to combine? No, they are not going to combine. At a certain spot only they can combine, right? Right? Are you get the point? And we need all of them to be combined all the time. When can two rays be combined all the time, all along? When they are parallel, right? So in a prism, we are using a prism so that to get non-parallel rays. That was the main reason of using a prism. That's the main reason of why we can observe dispersion, because the rays are not parallel. Okay. So never ever one would have thought that being parallel is such a big reason. Okay. Being parallel is the biggest reason over here of not observing a dispersion, and not being parallel is the reason of observing a dispersion. If things are not parallel, then eventually they will spread out. They will spread out and you can watch them over a screen. Is that clear? Is that clear? If things are parallel, they are not going to spread out also. Okay? Is that clear, people? Clear, clear, clear? Yes, no, yes, no, yes, no. If it is not clear, watch the recording. Okay, but is this clear that you have to write this as one of the answers? Please write that. Don't skip writing that. Okay? Don't try to be extra cool in the exams by saying, oh, let me just emphasize on the main reason and all and lose all your marks. Don't do that, okay? Don't do that. Don't risk your boards. Just write what they want to hear and then you can show off with other things in a very decent way. Is that clear? Is that clear? Okay, let us go on to the phenomena now.